Hey guys, so in this video, I'm going to show you how to find the volume of any 3D object. And I'm going to place emphasis on any object or any 3D shape because this general formula basically allows you to find the volume of any shape. So just to write down the formula. So the formula, which I'm sure you've come across many a times, V, which is volume, equals A, which stands for the area of the cross section times H. Okay, so in other words, the volume is area times height. Okay, so what does this mean? So basically, the best way that I can explain this to you is by using a loaf of bread. So if you imagine a loaf of bread, which I'm going to butcher. Okay, so take this as a loaf of bread using your creative imagination. This is a loaf of bread. So if you wanted to find essentially the volume of this loaf of bread, well, first you have to find the cross section. And the definition of the cross section is basically what is the shape that you obtain when you cut the 3D object in a particular way to constantly obtain that shape. A bit convoluted, but basically the cross section is the face that you constantly obtain when you cut the object in a particular way. And what's really important is that the cross section is always the same size, the same shape, with the same dimensions. So for example, normally you'd cut a loaf of bread like this, right? Across this way, you'd get your knife and you'd cut it along that way. And so if I was to do that, then the face or the shape of the cross section that I would obtain would be this face over here, right? Like when you cut a piece of toast, for example. Similarly though, I can probably cut the loaf of bread along this way like that. Probably won't do, but if you cut it along that axis over here and you kind of slice your knife through that way, the shape that you're going to obtain would be this shape over here, right? So that would be the cross section. And you'd basically cut it constantly along that axis, and every time you'd cut the shape and you'd look inside to what you've cut, you'd always obtain the same face, the same shape with the same dimensions, and that's the definition of the cross section. So going back to the first example, cutting the loaf of bread along this dotted line, so cutting it like you normally would, the shape that you would obtain is your toast, your piece of toast, which looks something like this, right? So if we're using this as our cross section, then to find the volume of this shape, we just need to take the area of this and then multiply it by the height. Now, the height in this example, I like to best explain it as the face or the distance between the front and the back, right? So in this example, the height would be over here. Because if this is the front, and the reason that this is our front is because that's the cross section. So this is our front and this is our back. And the difference or the distance between the front and the back is our height. And that's really important because sometimes you'll have different cross sections. You're not always necessarily going to cut it like that, but sometimes you're going to have to cut it like that, in which the height will not necessarily be horizontal, but will be vertical. But as long as it's the distance between the front or the back, or the front and the back, or the top and the bottom. So for example, if you had a cylinder, right? So you've got to think, okay, well, what is my cross section? How can I cut this shape to always obtain the same face? And so you can cut it basically along here. And if you cut it along here, you're always going to obtain this circle, right? Or you can also cut it along this way. But if you cut it along this way, you're not always going to obtain the same shape. Or rather, you're not going to obtain the same shape with the same dimensions. That's why cutting it along this axis would be the cross section. So in the cylinder, our height was a vertical distance, but in this loaf of bread, our height was a horizontal distance, which is totally fine. Your height is going to be dependent on the shape that you're dealing with. But it's important for you to recognize that what is the height in this formula, and the height is basically the distance between your front cross section and your back cross section. It's not necessarily mathematically correct, but it's the way that I prefer to look at it. And it's the best way that I explain it to my students, because I feel like that's the best way to visually grasp what you're dealing with. So let's go back. Let's finish off this loaf of bread. So if I wanted to find the volume of this loaf of bread, I would basically have to take the area of this shape. Now, it's not a perfect rectangle, but let's just assume it's a rectangle. So I would have to multiply it by, I'll give you some dimensions. That's 5, that's 3, and this distance here is 10. So to find the volume of this loaf of bread, I need to first find the area. So the area of this would be, because it's a rectangle, you just multiply the height and you multiply the height and the width. So that's 5 by 3, that's 15. So you multiply that area by the height. And the height, we know in this formula, is defined as the distance between the front and the back, the distance between the two cross-sectional faces. And so in this case, it's 10. So that will yield a volume of 150 units cubed. Okay, cool. And the same goes with this cylinder. You find the area of your circle here, and you multiply it by the distance between the front cross-section and the back cross-section, or the two cross-sectional faces, or the two extremes, or however you want to look at it, and that will be given by h, whatever distance that is. Basically, the main thing I think with these volume questions is knowing, first of all, you obviously need to know the area of your shapes, and just generally speaking, there's only like 3 different area formulas that you're really going to be using, and that is the area of any 4-sided regular shape, the area of a triangle, and the area of a trapezium. And we know that the area of any 4-sided shape is just going to be the perpendicular base times the perpendicular height, right? That's really straightforward, whether it's a parallelogram, a rhombus, a square, a rectangle, any kind of shape, any kind of 4-sided regular shape. It's just going to be the perpendicular base with the perpendicular height. With a triangle, we know the area is the base, half the base times the height, and the base and the height also need to be perpendicular. And with the trapezium, it's half the height times the sum of the 2 parallel sides. I'm not going to go through that in this video, but I'm just going to give you a quick overview, but just giving you a quick overview of your area formulas. I don't want you to get too cluttered in that world, because really there's not many formulas. I know in textbooks they kind of have lists of all these different formulas, one for a parallelogram, one for a rhombus, one for a trapezium, one for a square, but they're all really similar, and you got to think about this logically at the end of the day. So basically what I'm trying to say is, if you have a parallelogram like this with, 2 pairs of parallel sides, or if you have a rhombus, which is like a slanted square, where you also have 2 pairs of parallel sides but all the sides are the same, or if you just have a regular square, or if you have a rectangle, right? All these 4-sided shapes follow the same area formula, and that's length times breadth, or however you want to look at it. But the key thing with the L and the B is that they need to be perpendicular. So for example, if I gave you the base to be 10 and I gave you the slant height here to be 5, or if you take 10 as your base, 5 would not be your length. What would be your length is the perpendicular height that you make with the base. So that would probably be something like 4, right? Same with the square. If I gave you 5 and 5, you'd just multiply 5 by 5. The reason you don't have to necessarily worry about them being perpendicular in this case is because we know in a square, the sides are perpendicular, right? So we can just take 5 and 5, and same in a rectangle, you can take, say, 5 and 7, and you don't necessarily have to worry about them being perpendicular, because a rectangle, the sides in a rectangle are perpendicular. In a parallelogram, the sides are not perpendicular, which is why you can only take the perpendicular distances. But I just want to show you that they all follow this general formula, which is length times base, or base times height, or however we want to look at it. But what's important is that both your dimensions are perpendicular to each other. Okay, so the 4 is perpendicular to the 10. The 5 is not perpendicular to the 10. Same in a rhombus, I can give you this distance, this base to be 5, and this distance here to be 3. And because they're perpendicular, the area of this would be 5 by 3. okay? So in all these examples, they follow the same formula, length times base, or, you know, however you want to look at it, but they just got to be perpendicular. A triangle we know is half the base times the height. Same with this though, the base and the height need to be perpendicular, right? If you're given the base to be 7 and you're given this slant height here to be 5, the area for this is not half times 5 times 7, because 5 and 7 are clearly not right angled to each other. They're not perpendicular. So what you need to do is you need to drop this, find the perpendicular height, which you can find, you know, with Pythag, whatever it'll give you, and you multiply the 7 with this perpendicular height, which will, I mean, I don't know, maybe 4, who knows? Let's just say it's 4. Then it's half 7 times the 4. You see that? So the base and the height are perpendicular. That's really, really important. And that's what you find across all area formulas. All the dimensions are perpendicular to each other. And then finally, the trapezium. So the trapezium is basically when you have two sides that are parallel. That's it. Sorry, you have one pair of sides that are parallel, okay? It doesn't necessarily matter about these sides, but you know that these sides are not parallel. If they were parallel, then we'd have a parallelogram. But a trapezium, in this case, is just two sides or one pair of sides in which are parallel. So the area of a trapezium is basically half the height times the sum of the two parallel sides. So once again, perpendicular height, right? You get the perpendicular height, you get the base here, and then you've also got the other parallel side. Let's just say it's got a distance of A. So the way that I like to do it is I add the two parallel sides and I multiply that by the perpendicular height and by half. Okay, so let's have a look at a few examples. So this was just area. But the main focus of this video is obviously how to find the volume of the shapes. So just to recap, volume of any shape, area of the cross-section times the height. Cross-section is the face that you always obtain when you cut it in a particular way. And the height is the distance between the front cross-sectional face and the back cross-sectional face, or the top and the bottom cross-sectional face, depending on the way that you cut the shape. I hope that makes sense. Let's have a look at a few examples. Actually, before we have a look at a few examples, I just want to cover one exception. And that exception is in the case of a pyramid. So this formula basically holds true for any prism. In the case of a pyramid, it's a little bit different, just a touch, nothing too crazy. Okay, so the volume of a pyramid is basically a third times the volume of the respective prism, right? So if we know that the volume of any prism is the area of the cross-section times the height, then the volume of the pyramid is a third times the volume of the prism, which we said was the area of the cross-section times the height. But I'm going to make a small adjustment here. And instead of the area of the cross-section, it basically is the area of the base. So I'll give you a quick example. So the easiest one to start with is basically a cylinder. So I gave you the example of a cylinder before. So for cylinder, so here we have a cylinder, kind of, and we know that the cross-section of the cylinder is the circle. So to find the volume of the cylinder, we times the area of the circle by the height of the object. Let's just say we had this prism's respective pyramid. So what that means is that we turn this into a pyramid with the same base. So it's got a circular base, but all the sides kind of join to a point to make a pyramid. Then the volume of this pyramid is a third of the volume of the cylinder. Okay, so all that means is to find the volume of this pyramid, you take a third times the volume of the cylinder, which was the area of the circle, times the height of the shape. Now, it's not necessary that you find the prism, the respective prism. It's just basically necessary for you to identify the base of the pyramid and then multiply it by the height of the object. Another example would be a square pyramid. This is really common. Let's draw a square there, and all the sides kind of join to a point. So the volume of this is 1/3 times the area of the base, which is a square, times the height of the object. And we know the area of the square would be this times this, whatever it is, and when we times by the height. So just as a quick recap, so we have the volume of any shape, specifically a prism, is the area of the cross-sectional face times the height. But then we make a small adjustment for a pyramid. The volume of a pyramid is 1/3 times the area of the base times the height. Okay, so those are the two formulas that you really need to know. Let's have a look at a few examples now. Okay, so this question is from HSC 2018, question 13. So it's a multiple choice question, and it reads, so we have a rectangular pyramid. So the base of the pyramid is a rectangle, and it has length 4x and another side length of 3x. It says the perpendicular height of the pyramid is 2x. What is the volume of the pyramid in cubic meters? Okay, nice and easy, hey? Think back to the formulas. I gave you two formulas. The first formula was the volume of a prism, and that was the area of the cross section times the height. And then we have a volume of a pyramid, which is basically just 1/3 times the top formula, but we write it as the area of the base times the height. All right, here we're dealing with a pyramid, so we're going to obviously use this formula. So the first thing we need to find is, okay, what is the area of the base? So the base is a rectangle, so the area of a rectangle is the length times the breadth. So the length is 4x, the breadth is 3x. So 4x by 3x gives us 12x squared. And the height of the shape is given to us in the question, which is 2x. Therefore, the volume of this pyramid is 1/3. So whenever you have a pyramid, you always got to have the third. Just don't forget that for a pyramid. So 1/3 times the area of the base, which we calculated up here as 12x squared. And we multiply that by the height, the perpendicular height of the object, which is 2x. And this is just a matter of simplification. So 1/3 times 12 is 4. 4 times 2 is 8. And we have x squared times x, which is x cubed. And that leaves us with option A. Okay, let's have a look at this next question. So this is from the HSC 2017 paper, General Maths. And it's question 18, also a multiple choice question. Let's have a quick read. So this is a skip-in. It's in the shape of a trapezoidal prism, which means it's got a cross-sectional face of a trapezium. It literally gives it to you in the question, and its dimensions are given. So your job is to find the volume of the bin. First of all, it's a prism. So we know the volume of any prism is as follows. It's the area of the cross-section times the height of the object. So let's start with the area of the cross-section. So what is the cross-sectional face? And the cross-sectional face is a trapezium. The first reason I know that is because it's given to me in the question. But you've got to think about, okay, how can I cut this object to always obtain the same shape? And if you cut it along this line here, and you kind of slice it like that, along the front and towards the back, you're always going to obtain this front trapezium over here. So that's the area we're going to find. We know the area of the trapezium, as I stated before, is half the height times the sum of the two parallel sides. So the two parallel sides is this and this. And the height, which we know is the perpendicular height, is 1.2 over here. So for 1.2 divide 2 times the addition of the two parallel sides, which is 3.6 plus 2.4. And you pop that into the calc and you get a reading of 3.6. So this is the area of the trapezium. So that's in meters squared. And then the height. So what's the height of the shape? So we know the height is the distance between the two cross-sectional faces. So if we assign this to be our front and we assign this to be our back, then the distance between the front and the back is 1.5. So that becomes our H in our formula. So therefore the volume of this prism, this trapezoidal prism, is the area of the cross-sectional face, which we got as 3.6, times the distance between the front and the back, which is 1.5, which we get as 5.4 meters cubed. So that also leaves us with option A. And lastly, question 22. So this is the same paper, 2017. This is also a multiple choice question. So question 22 states, a concrete water pipe is manufactured in the shape of an annular cylinder. Okay, an annular cylinder is basically a cylinder with a cross-section of an annulus. So an annulus is basically like a donut. The dimensions are shown in the diagram. So this is lovely. They give you the they give you the cross-section right here. So that makes your job a lot easier. So all you need to find, or all you need to do to find the volume of this shape is find the area of the cross-section and multiply it by the height. So what is the cross-section? Well, the cross-section is given to us as the annulus. So in order to find this shaded bit over here, then basically what we need to do is we need to find the area, the total area of the largest circle, and subtract it from the area of the inner circle. By doing that, we get basically the annulus, what's left over. So the area of the largest circle is pi times the radius squared. The radius of the largest circle is 0.35 plus 0.1, which is 0.45. We square that, and we subtract it from the area of the smaller circle, which is pi times r squared, and the radius of the smaller circle is 0.35. So that gives me a reading of 0.25. So that gives me the area of this annulus over here. So that's the area of the cross-section, and then we multiply that by the height of the shape. So the distance between the two cross-sectional faces, the extremes, so that would be the front here and the back here, because we're cutting it along this way, right? And the distance between those two is 2.8, so that's our height. So to find the volume of this shape, we're going to multiply 0.25 by 2.8. And it's also really important to make sure that the units are consistent. So the units here we used were meters, and the units here are meters, so that's fine, that's sweet. But that's just something to kind of keep your eye out for. So we get 0.70 meters cubed. So that leaves us with option C. Perfect, so that's just a few examples to show you how to find the volume of any shape using quite a basic formula. And just basically using a bit of logic. I think volume and area and all that kind of stuff is probably the simple side of maths, I'm going to say, only because it's the most logical side of maths, and it's very visual, you know. It's kind of easy because you can see it. It's not as abstract as algebra can be, or as other mathematical concepts can be. So anyway, I hope this helps, and if you have any questions, leave them below.